Hello, today I am going to be explaining how a 3D printer works and what is a 3D printer by me. So, let's start at the basics. What are the two main types of 3D printing? So, the two main types of 3D printing, there are more types of 3D printing, like more advanced types, but the two more popular types are FDM and SLA/DLP/resin. So FDM printing uses filament to print. Resin printing uses resin to print. So they're very different and similar at the same time. FDM printing will basically maneuver this print head and bed and basically maneuver the printer to extrude the filament and basically build up in layers to build the object. Resin printing is a bit more different, where this is the print bed, and I will go more in depth later in the video, but basically there's a UV light under here, and then there's this resin here, and it will basically cure that resin into this object. So I'll go more in depth into these later in the video, but I just thought I'd give a simple explanation of both of these. So 3D printing is basically taking an object on a computer and then turning it into a 3D object in real life. So it's kind of like Legos, where you go step by step, layer by layer to build the object, to slowly make the object, basically. So these are the main components of a 3D printer. There's the print bed. Wait, this is the wrong print bed. This is the print bed. So the print bed is the part of the printer that the printer actually does the printing on. So on here, it's basically this platform here that the printer will print on. So you can see here, the printer is just printing this object on the print bed. The print bed usually is heated, and that's because when the filament gets extruded from the nozzle, it's very hot. And the air is not very hot, and this print bed, if it wasn't heated, would kind of be cold, because it's extruding at like 250 Celsius, maybe higher for even ABS and PTG. So the temperature difference is pretty big, and when the filament cools, it shrinks, and that causes warping, where basically the print will kind of unstick itself from the bed, and like it'll kind of warp up, and that will cause the print to fail. So the print bed is heated to make that temperature difference less, and also it helps the filament stick to the bed. So that's why the print bed is heated. There's not really that much else to the print bed. One thing I will say is when you're printing more high temp filaments like ABS and PTG, usually you're gonna see printers that do that have enclosures. I mean, you can do it on any printer, but it's harder to do it on one of these printers where it's not enclosed. So the reason you need an enclosed printer is the air temperature. It can basically increase because of the bed is heated, and that will heat up the air around it, and that will make the temperature difference less, which will make the filament warp less and increase the chance of the print succeeding. So the print head / extruder. So what is the extruder? What is the print head? So the print head is the part of the printer that actually does the printing. So this is the print head. There are two different types of extruders. There's direct drive, and then there's Bowden. So direct drive is where the filament will come in, and then it will come through here, and then it will get pushed by this gear through down this tiny tube into this heat sink. And what this does is heat that comes from here, which is basically the heater block. Well, this is what heats up the filament, and also what heats up the nozzle so that it can come through. So heat rises. So the heat will rise up into here, and if the filament melts in here, that will basically make the filament soft, and it's trying to push the filament through, but it'll be soft and like clog up, and you don't want that. So there's a heat sink here, because basically there will be a fan that blows on the heat sink, you can see here, and that will cool this down so that no heat gets in here. Then the filament will continue through down into the heater block, and then through the nozzle will then be extruded to make an object. So a Bowden type extruder is where this motor, basically this part of the extruder, is just cut off and put usually on the side of the printer, as you see here. So the filament will come through, get pushed through by this motor, through this tube, and then into the nozzle, and then out to make the object. So the disadvantage to this is if you're printing flexible filaments, the filament will usually clog up right here because there's so much resistance going through the tube and then through the nozzle. So usually it'll just clog up right here, which is why I use a direct drive extruder to print flexible filaments. And also, let's say the printer wants to print this, and it needs to travel from here to here without extruding any filament. So obviously the motor would stop moving, the extruder motor, because you don't want to extrude the filament. But there's still hot filament in here, and it will usually kind of seep out and come out, and then that will cause stringing, which is where filament gets extruded where it's not supposed to be extruded. So what a direct drive extruder, this is where direct drive extruders have another advantage, is retraction. So that will basically pull the filament out. The extruder will pull the filament out, and then it will come up, and now the filament's right here instead of right here. So it can't really come out of the nozzle. Versus Bowden, where it's kind of harder to do that because there's such a long distance between the motor and the hot end. So usually you get more stringing on a Bowden type extruder. An advantage on a Bowden type extruder is because you don't have this big motor on it, it's lighter, so it's easier to print fast. But really, that's the only really advantage to Bowden, and direct drive, in most cases, is the better type of extruder. So axis. There are three main axes on a printer. There's the X, Y, and Z or Z. So the X-axis moves from side to side. The Y-axis moves back and forth, and the Z-axis moves up and down. So on this printer, you can see the X-axis is the extruder, or a hot end, or print head, whatever you want to call it, moving side to side. The bed is moving on the Y-axis back and forth, and then there's these two little brackets on these poles that have these motors on the bottom, which moves basically this bar for the X-axis up and down for the Z-axis. On this printer, it's a lot different. This has the X and Y-axis at the top here moving back and forth, so the extruder still moves on the X-axis, but you can kind of see here, this is one of the belts for the Y-axis. So in the back here there's a motor, and then it will move these belts, which are attached to this X-axis bar, which will move back and forth for the Y-axis, and then the bed will move up and down for the Z-axis. So actually, before I move on, there is another type of printer here. So this printer is special because it doesn't really have an X, Y, or Z axis. How this printer works is there's your extruder, and there's three bars attached to it. Now let's say this bar moves up. This will move the extruder to the left. This bar moves up. This will move it. Well, actually, this will move it to the right if this bar goes up. If this bar goes up, it'll go to the left. If this bar goes up, it'll go backwards or forwards, depending on how you move it. So basically, you can use these to manipulate the extruder to go in different directions. So this doesn't really have an X, Y, or Z axis. And then on resin printers, there's only one axis, the Z axis. So I'll actually go more in depth on resin right now. So how a resin printer works is there's the printer, and then there's a little screen under here. And what basically happens is, actually I'll do a little drawing here. So let me make this bigger. Alright. No, go back. So basically there's this screen right here. Now under this screen, here I'll draw a sideways view, So let's say this is the screen. Under here is this UV light. So let's say this is the UV light. This light will shine UV light up into the screen. Now, let's say this is the top view of the screen. Let's say you want to draw a circle, or let's say you wanted to make a cube. So, let me erase this. If you wanted to make a cube, there would be all this UV light trying to come through the screen. Now, this is not like a screen on your computer. This is a screen where it blocks light. So, if you'd have a bunch of UV light coming up from here, and then this screen would let light come through in certain spaces and block it in certain spaces. So, let's say the red line, or let's change the color. Let's make it purple, because UV light is kind of purple. So, everything here is just black. Pretend all this white and this red box is black. Now, this purple box is the UV light that the screen is letting come through. So, it would basically, the bed, this part would be very close to the screen, and it would let's say it's 1 millimeter from the screen. Then it would let this UV light come through, and it would cure 1 millimeter of this box. And then it would go up, and it would cure another millimeter, and go up, and cure another millimeter. So, there are videos on YouTube that probably explain it better than this, but this is just my quick explanation, and then it will make your object. So, that's my quick explanation of how resin printing works. Now, it won't change slides. So, filament. There are a lot of different types of filament, as you can see here. There's even more than this. But there's a few main types of filament people would print with at their home. PLA, ABS, PETG, TPU. Yeah, that's basically it. I mean, some people, you can print nylon, ASA, but if you went to the store, let's say you went to Micro Center, usually you'd pick up PLA, ABS, PTG, or TPU. PLA is a very simple to print, easy. It just works most of the time. You don't need that much tuning on your printer. It just works. ABS is more of a high temperature filament, so you'd most likely need an enclosure, higher temperature bed, more capable printer that can have a higher temperature nozzle and everything. PETG is a more durable filament. So what I found was it has a tiny bit of flex to it, and what that does is if you were to throw, let's say I printed a cube in PGD, you were to throw it at the floor, instead of it being brittle like PLA, it would absorb the impact, and it would basically be more durable. TPU is a flexible filament, so yeah, basically just flexible. There are more types of filaments. Actually, now people are starting to print metal. Usually those are on higher end printers where you can get metal, and you can print metal. Metal infused filaments. There's also like wood infused filaments, like even PLA. There's wood infused PLA. There's different types of these, like silk PLA, wood infused PLA. So yeah, there's a lot of different types of filaments, and now filaments are starting to develop more. So, Slicer. So this is the software that basically, you have the file on your computer. So we have our cube. Let's get our red cube. Okay, so this is our red cube. Now, how do we take this horribly drawn red cube and turn it into something that my printer can actually print? So, this red cube is just a .stl, or a 3D file. Now, the printer doesn't know what a 3D file is. So, in order to turn this into something the printer can read, you use a slicer. So, basically, the printer actually doesn't know what it's printing. So, the printer is just reading code and doing what it's told to do. It actually doesn't know what it's printing. So, if we go back to a slide where you can see a printer. What the slicer will do is it'll take my cube, my 3D cube, and it will turn it into code. It's called GCode. It'll usually be like G something something X and then like 107, Y something, like maybe 3, and then Z 5. And then extruder, and then it's more advanced than that, but like that's the simple basic of how GCode looks. So what that'll do is, let's say, actually let me just write it down. So let's just say it's G and then X1, Y2, and then Z3. So what this will do is 1, 2, and 3 represent a position on the axis. So on the x-axis, there's position 0, which is where the end stop is. Here, this is the end stop. It's harder to see on newer printers because they're not really using traditional end stops. They use like... Anyway, back to the point. Basically, they just use like tension, like the printer can measure the tension of when it's close to it, or light sensors or stuff, but this is your traditional end stop. So what this will do is when you start the print, the x-axis will home, and basically the print head will move. It'll keep moving this way until it hits this. And now the printer will know, okay, x-axis is at 0. Y-axis will do the same. 0. Z-axis, this is the Z-axis end stop. It'll go up and it'll say, okay, now everything's at 0. Now we can start. So if we go to our code here, it means x1. So let's say it knows it's at 0. So now it can move it to 1, and now it knows it's at 1. Y2, it can move the y-axis to 2, it knows it's at 2. Z3, it can move the z-axis to 3, and now it knows it's at 3. So one problem with the system is, let's say you bumped into the printer, and it skipped a step, which means the motor was trying to get, let's say the y-axis was trying to get to 2. Now what will happen is, if you skip a step, basically, the motor will think it's at 2, but because you bumped into the printer, and maybe it like, what's a good way to explain this? So take like a fan, any fan, and if you stick your finger in the fan, don't do it, but if you were to stick your finger in the fan, then the fan would stop, then that's kind of like a printer skipping steps, except it's a different type of motor. It's a stepper motor, which means there's tiny little increments it moves in. So if you were to skip a step, it means the motor stopped, it tried to move somewhere, it thinks it moved to that place, but it actually didn't. And now your print will be shifted. So a drawing of this would be like this. This is my box. And let's say the X wanted to move to 2, but it couldn't. So now it'll keep printing, and the box will look like this. Because it thinks it's here, but it's actually here. So I just thought I'd say that. So don't bump into your printer. But that's why, that's basically how end stops work. So the slicer will turn that 3D file into code that the printer can read, and then you'd put it on a USB stick or SD card, or plug your computer into the printer, or even you can do it over Wi-Fi using Octoprint. Octoprint is kind of like a software. You can put it on a Raspberry Pi, plug it into your printer, and you can basically control your printer from anywhere. But you can do it over Wi-Fi or whatever, and then the printer will receive that code and print. So, how to 3D print something from start to finish. So, I actually designed this presentation. I was presenting this PowerPoint. Actually, you can see that video on my channel. I just uploaded it a few days ago. So I fully explain how to 3D print something there, but I'll just go through it quickly. So you want to get your file from, let's say, there's a lot of websites you can get your files from. Tinkercad is a website you can design a file, but Thingiverse, Printables, My Mini Factory, and this is kind of annoying because if you want to find something, there's all these different websites that file could be on. Someone could have designed, basically someone designs the file and uploads it to those websites. So there's all these different websites, and if you want something, you don't find it on Thingiverse, you go to Printables, and then you go to My Manufactory, and it's annoying to like go through all those websites. So there's a website that I found. It's called Thangs, THNG. I forget how it's spelled. Thangs. You can search it. Basically, it'll go through all the websites. Actually, here, I'll just show you. So, Thangs. Basically, it'll go through all of the different websites and put them into this website. So if we want our cube, you can see it'll tell you the website it's on and give you the file. So this is Thingiverse. These are all Thingiverse. I'm looking for something that's not on Thingiverse. Here, this one's on Printables. See if I can find one that's on My Manufactory. Anyway, you get the point. It basically goes to all the major STL websites and will find the file. You can click on it, and then it'll actually go to the Thingiverse. So if you already know how to 3D print and you're into 3D printing, this one's for My Manufactory. This is a good website you should use. If you're getting into 3D printing, also a good website you should use. I use it. I don't actually use Thingiverse or whatever. I just use this website because it saves a lot of time. Anyway, so once you download, I don't actually have a slicer on this computer, so I'm just going to have to explain. Where'd my PowerPoint go? Okay, so once you get your 3D file, you're going to go into the slicer, adjust some settings. Nowadays, printers usually come with presets, and on most popular slicers like Kira, Prusa Slicer, have presets for most popular printers. So you just get a good brand of filament. This is one recommendation. Get a good brand of filament, because otherwise you're just going to get cheap filament that's probably old, and by old I mean like it's been sitting in a warehouse for a long time, and what happens is humidity, the water and the air can ruin the filament and make it brittle and turn it into trash. So just make sure you get a good brand of filament, and always make sure your filament is dry. I have a filament dryer. You can store it in you can vacuum seal to store it. PLA doesn't really have this issue, but ABS, PTG, all those filaments do get affected by humidity. PLA does, but not as dramatically as other filaments do. So you put it in your slicer. You can just use default settings. There's a few videos on YouTube where they'll show you how to go through the settings and tune your printer, tune your settings, which basically means adjust retraction, adjust how fast it goes, adjust basically all the settings, and then that will make your prints better. But default settings work good. So you can just download it to the SD card, plug it in the printer, and now you have your print. So what 3D printers I have? So my dad got this printer for me, I think when I was like 8. This was a horrible printer. It was a Prusa i3 V2. This was back in the time when RepRap was big, when 3D printers were when 3D printers were new, basically. So it was a horrible printer, parts were missing, you had to like put it together fully, and it barely printed. It printed half the time, probably 80% of the time the prints would fail. And even when it did succeed, they looked horrible. So then he got this printer and said to start an Etsy business. So this actually shows how much printers have evolved. This printer only took like 15 minutes to build, set up, well, maybe 30 minutes. But really easy to use. It came with all the presets and everything. And this is how I really got into 3D printing and started my Etsy shop. And then I bought this printer. So this is the Flash Forge Creator Pro 2. This is the Creality Ender 5 Pro. So this is an IDEX printer, which means it has an independent x-axis. It has two individual extruders on the x-axis. So what this allows you to do is print multiple prints in the same time it would take to print one. Because let's say I'm printing a cube and a cube. Basically, you could have the y-axis moving back and forth to print part of it, and then these individual x-axis are basically printing while it's doing that. So it can print two things in the time it takes to print one. And then also it's fully enclosed, so it's easier to print higher temperature filaments. And if you get a fully enclosed printer or you just get an enclosure for your printer, you'll see the difference in printing ABS and PETG is amazing. And also, it's direct drive, so I can print TPU now, which I couldn't do on this, which was annoying. So that's the end of my... Oh, that's not the end. I forgot. So these are some things that are 3D printed. This is a 3D printed house. How this works is there's a big machine that will come, and then it'll basically just extrude concrete and layer by layer make the house. And then this has an interesting story. So there's a guy who always wanted a Lamborghini, but he couldn't afford one. So he bought a 3D printer and piece by piece made the Lamborghini, bought an engine, put it in the back, and now he has a 3D printed Lamborghini, which I think is cooler than a real Lamborghini, because, like, you can tell, there's not many people that actually have a 3D printed Lamborghini. So I think this is cool. And this shows how 3D printing is evolving beyond your normal house 3D printer. Also, now there's 3D printers in hospitals, 3D printers in the ISS. There's 3D printers being used for a lot of things that are way beyond just your normal home 3D printer. So, like I said, this was designed to be a presentation, so I have a question slide, but that is the end of my PowerPoint on how 3D printing works. I hope you enjoyed, I hope you learned something, and I'll see you in the next video.